Welcome to Matrices and Determinants class. The class is exclusively for CA Foundation students and the CMA Foundation students. This chapter is included as one of the chapters in your maths and the new syllabus. So we are going to learn about what do you mean by matrix, how to construct a matrix, what are the different types of matrices, how to add them or subtract them, or how to multiply the matrices, and what about minor cofactor of an element of a matrix, and how to construct a cofactor matrix, adjoint matrix, and of course inverse. In addition to that, you will be learning how to get the value of a determinant and how to use this determinant method to solve the equations containing 2 variables and 3 variables. Those who have learned matrices, it will be a revision class, and for those who have not at all learned, we will be teaching you from the fundamental so that you will be thorough and you can answer any type of multiple choice question asked in your examination. We are very much sure that if you understood the practice, understood all the concepts and work out the problems at least once after learning from here, you will not find any problem tougher than this in your exam. So with this, we'll go to the class. Matrix. What is matrix? Matrix is simply a rectangular arrangement of some elements, some numbers. It can be anything. The different batsmen and the runs scored by them in different matches. We can put it in a matrix. So it's simply a rectangular arrangement of some numbers, horizontally as well as vertically. The horizontal lines is known as rows. The vertical ones is called as columns. This is row, horizontal one, and this one, vertical one, is known as columns. Generally, we represent a matrix in this way. So the numbers are written here, and we are enclosing with a square bracket, or it can be a simple bracket also, normal bracket. That is why we call it as open bracket. It can be a square bracket or an open bracket. Within that, you will be writing the numbers. To specify the element, we are using this notation, Aij. What do you mean by the Aij? The element in ith row and jth column. Ith row, jth column. For example, this element is in first row, first column. This element is in first row, second column. And this one let me take, this one is in second row and third column, and so on. So generally we write Aij is equal to like this. The matrix, the rows and columns may be equal, need not be also. If the rows and columns are equal, then it is a square matrix. Otherwise it is a rectangular matrix. A matrix can be simply a row. We call it as a row matrix. Simply one row. No other rows. With any number of columns. Or it may have only a column. No more columns. Only a column with different rows. Column matrix. So it can be square matrix, rectangular matrix, row matrix, column matrix, and further matrix is also possible. You will see that. First, let us know what is meant by order of a matrix. Order of a matrix is number of rows into columns. Suppose there are 3 rows and 2 columns. You will write the order as 3 into 2, 3 by 2. Don't multiply and give the answer as 6. Just leave it as 3 rows and 2 columns means 3 rows, 3 by 2, 3 into 2. If it is 5 rows and 2 columns, 5 into 2, 5 by 2. Now, how to construct a matrix? Well, the element is defined like this. Aij is equal to 2i minus 3j. I told you Aij means element in the ith row and jth column. So 2 by 3 matrix you are asked to construct. 2 rows, 3 columns. 2 rows and 3 columns. You write down the matrix general form. A11, A12, A13. First row, first column. First row, second column. First row, third column. Similarly, A21, A22, A23. In this one, Ij, you substitute these values. For A11, you substitute I equal to 1 and j equal to 1. 2 ones are 2 minus 3. For A12, put I is equal to 1, j is equal to 2. 2 ones are. Then here 2 into 3. For A13, put I is equal to 1, 2 into 1 minus. For j you put 3, 3 into 3, 2 minus 9. Similarly for the second row, A21, for I you put 2, 2 2s are 4 and this is minus 3, minus 1 into 3. For this one 2 into 2, 4, 2 into minus 3, minus 6. And this one 2 into 2, 4 and 3 into minus 3, minus 9. Therefore the result of the matrix is 2 minus 3, minus 1, 2 minus 6, minus 4, 2 minus 9, minus 7, 4 minus 3, 1, 4 minus 6, minus 2, 4 minus 9 is minus 5. So this is the matrix. This is how you have to construct it. So now you know what you meant by or what the order and also how to construct a matrix under the given condition. Row matrix. Again I am going for the types of matrix. Row matrix already I said. Now it's in the board also you can see row matrix. It contains only one row. It can have any number of columns. In this given example, it contains one row and there are 4 columns. Therefore the order of matrix is 1 into 4, 1 by 4. Column matrix, it will contain only one column. They have any number of rows. So first row, second row, third row, fourth row, fifth row. Therefore 5 rows are there. So order is 5 by 1. Square matrix I said that rows and columns will be equal. So what do you mean diagonal matrix? This one we call diagonal. So it is a square matrix and these elements we call it as diagonal elements. So in the diagonal matrix you will have elements only here. At all other places you will have only zeros. All other places zeros except the main diagonal. The main diagonal will have some elements. If it is a scalar, same thing, the same diagonal matrix, just like that, it's a square matrix. The main diagonal will have same elements. If it is 7, 7, 7, or it may be 100, 100, 100. So these numbers should be the same. And if these numbers are each one equal to 1, then it is identity matrix. Identity matrix or unit matrix, we call it. So I2 means 2 rows and 2 columns. I3 means 3 rows and 3 columns. In case all the elements are 0, then it is called as 0 matrix. Upper triangular matrices and lower triangular matrix. Upper triangular matrix, all the elements below the main diagonal are 0. All the elements below the main diagonal are 0. So it forms a triangle like this. So this is a triangle, isn't it? So in the upper portion we are finding a triangle. So we call it as upper triangular matrix. Similarly we can go for lower triangular matrix then. In that case all the elements above the main diagonal will be 0. Otherwise we will be getting a triangle here in the lower side. So this is a lower triangular matrix. Submatrix. Suppose a matrix is given, you can write this its submatrix is as omitting the first row and first column I omitted. This row and this column I omitted. Result is that 5 minus 1 and 4 1. I mean we are getting 2 by 2 matrix. That matrix we call it as submatrix. Now we will be seeing what is meant by 2 matrices or under what conditions the 2 matrices will be equal. Equal matrices. 2 matrices will be equal if the order is same. If the first matrix is 2 by 2, second matrix also should be 2 by 2. If it is 3 by 3, second one also must be 3 by 3. The first one is 2 by 3, second matrix also must be 2 by 3. Same order. Corresponding elements must be same. What are my corresponding elements? For example, I have written two matrices A and B. So A matrix I have put it as A11, A12, A21, A22, and for B matrix I have put B11, B12, B21, B22. The order of this matrix is 2 by 2, this is also 2 by 2. And if A must be equal to B, then this corresponding element, the first element, must be equal to the first element in this matrix. A11 should be equal to B11. This element should be equal to this element. That means A12 should be equal to B12. Likewise, A21 should be equal to B21, A22 must be equal to B22. If so, then the matrices are equal. So question definitely will be asked based on this. They will be giving you two matrices. They will say they are equal and ask you to find out some x, y, z unknown. Okay, we will see that. So problems based on equal matrices will be like this. So in the first problem, x square minus 1, 3, 5, x square plus 1 is in one matrix. In the other matrix 8, 3, 5, 10. The corresponding element should be equal and the order also must be the same. Order is same here. Corresponding elements we are equating it. 3, 3, same number is there. 5 also same. Only thing here we have some different numbers. X square minus 1, that is equal to therefore 8. And x square plus 1 should be equal to then 10. According to the principle of that equal matrices. In this case x square equal to 9, that means x equal to plus or minus 3. In this case x square plus 1 is 10, therefore x square to 9. Here also x equal to plus or minus 3. So we come to conclusion that the x value may be plus or minus 3. I am taking another example. So in the first matrix x square is there. In the second matrix first element is 9. So for equating that x square equal to 9 or x equal to plus or minus 3. In the second matrix the 5x is equal to minus 15. In that case x must be equal to minus 3. So you have to choose the value of x which satisfies both the equations, both the number, this. So x equal to plus or minus 3, here x equal to minus 3, therefore the value of x must be equal to minus 3 only. Because minus 3 satisfies here as well as here. So you must be careful whenever the problems are like this. We will do more problems after some time. Now we will go for how to do additions and subtractions. Addition of two matrices. Addition and subtraction of matrices possible only for the same order. The order of matrix must be same. If the order of A is 3 by 3, order of B also must be 3 by 3. Subtraction also likewise. Because corresponding elements we are going to either add or subtract. So the first example I have taken how to add the matrix. Very simple one. Just the corresponding elements will be added. There is a plus sign. So you are adding this 5 with 10, 15. Minus 6 plus 8. So 8 minus 6 is 2. And 8 plus 4, 12. 12 plus 5, 17. That's all. Subtraction, similar to the previous one, or just like any algebra. So here is my minus 101 minus 85. So 16. Minus 100. Here is minus. Here inside also minus. Of course you know that minus and the minus will be plus. So plus 30. Minus 100 plus 30. Therefore minus 70. And this one is minus 98 and this is also minus 10. Therefore minus 98 minus 10 minus 108. And here is minus, therefore plus 95. So this will be, so not a correct one. So 95 minus or minus, so it should be 115. Now, what do you mean by negative matrix? Negative matrix is, if a matrix is given, change the sign. For example, A matrix is given as this, minus 402, 804, 55, minus 67. Therefore, the negative matrix will be equal to minus sign here, therefore plus. Plus sign is here, therefore minus. Plus, therefore minus. Here is minus, so you are adding plus. So, that's about the negative matrix. Here there was a mistake, so please note that this will be 95 minus or minus plus, therefore it will be 20 plus 115 is the answer. Scalar multiplication of matrices. That is, the matrix is multiplied by a scalar other than 0. Suppose A matrix is like this and you have to get the value of 5 types of A matrix, that is 5A. Each and every element should be multiplied with 5. That's all. 5 6 are 30, 5 into minus 2 minus 10, 5 4s are 20, and 5 zeros are 0. Suppose I have taken another example. A matrix is given. I am asking you to find out minus 12a. Simply as it is, you have to multiply with minus 12. That's all. So minus 12 into minus 2 plus 24, minus 12 into 5, minus 60, minus 12 into 6, minus 72, and minus 12 into 7, that is minus 84. So scalar multiplication is very simple. Now, we are going for another term, that is transpose of a matrix. What do you mean by transpose? Suppose the matrix A is here, I have written the transpose. What do you mean by transpose? If the rows and columns are interchanged, the rows are interchanged. The second row, second column, third row, third column. The rows and columns are interchanged. The resulting matrix is called the transpose of the first matrix. So we represent as A as a line upon that. So A dash. So A dash is the transpose matrix, and you must remember, you must know that transpose of a transpose. So if you are again transposing this, you will get back this only. So that's a property here, A transpose and the transpose of that. That will be equal to always A. Symmetric matrix. What do you mean by symmetric matrix? Even after transposing A, you will get the same thing. A will be equal to A transpose. If so, then that matrix we call it as symmetric matrix. For example, here 4 minus 2 6, minus 2 5 4, 6 4 minus 8. This first row comes here. The second row comes in the second column. Third one 6 4 8. So minus 8. So I should have written minus 8 there. So minus 8. So it will be the symmetric matrix. So then in that case, A we call it as symmetric matrix. So A is equal to A transpose. So I have put here T. That means that A transpose, or you can simply put a line. Both are same. So generally they use the notation like this. So if you are changing the rows into column, 4 minus 2 6 here, minus 2 5 4 here, 6 4 minus 8 has come over here. So the matrix that you are getting is the same matrix, then we call it as a symmetric matrix. What do you mean by skew symmetric? Matrix A must be equal to negative of A transpose. For example, A matrix is this, then A transpose will be 0AB minus A 0D. So I am writing here minus B minus D 0 here. If you put minus, what will be getting? See, this will be plus A plus B. This is minus A and plus D. This is minus B minus D. So A matrix, if A matrix is equal to minus of A transpose, then that matrix we call it as skew symmetric. In this skew symmetric matrix, you will be finding that the diagonal element is 0. So it will be easier to write this skew symmetric matrix. So with the help of a matrix, can we find out symmetric as well as skew symmetric? Yes, we can. There is a formula. If a matrix A is given, then we can find the symmetric matrix by the formula A plus A transpose will give you symmetric matrix. And similarly, to get this skew symmetric, we can use A minus A transpose. You will get this skew symmetric. Now we are seeing on the board the properties of transpose matrices. Transpose of transpose matrix is A plus B. The summation, you are getting one matrix, and the transpose of A plus B is equal to transpose of A plus transpose of B. A scalar matrix, K times of A matrix, transpose of that is equal to K times of only A transpose. K into A transpose. And just now we have seen that A plus A transpose is symmetric, A minus A transpose is skew symmetric. Therefore, if you are adding these two, this get cancelled. 2A is equal to symmetric plus skew symmetric. Therefore, A matrix can be said also equal to symmetric matrix plus skew symmetric, the whole thing divided by 2. These are the properties which you have to remember for answering the multiple choice questions. Matrix multiplication. Multiplication is possible only if column of the first matrix must be equal to rows of the second matrix. For example, if the order of A is m rows and n columns, order of B is p rows and q columns. These two matrices you can multiply only if this n will be equal to p. These two should be equal. That's what I said, that column of the first matrix should be equal to the number of rows of the second matrix. AB is defined only if the n is equal to P. Otherwise, matrix multiplication is not possible. In that case, what will be the order of the resulting matrix? Say order of that AB, the resulting matrix is, what is left out? M rows, and here Q. Therefore, M into Q. M by Q will be the order. Generally, matrix multiplication is not commutative. Remember, AB is not equal to BA. You cannot take it for granted that AB is equal to BA, as you are doing in the case of algebra. Matrix algebra, matrix algebra, the multiplication is not at all commutative. Most of the cases. Exception is that A into adjoint A will be equal to adjoint A into A. The answer will be always determinant of A into I. That is unit matrix. This always holds good. So, in this case, it is an exception. Mostly, we say that that's why generally AB is not equal to BA. Associative property holds good. So, you are given three matrices. You can multiply in any order. A into BC. BC you do that first and then multiply with A. Or find out AB first and then multiply with C. You will get the same answer. It holds good distributive property also. A into B plus C is equivalent to AB plus AC. Suppose AB equal to AC. You are finding out the product of AB and you are also finding out the product of A matrix and C matrix, and you are finding that both are equal. That does not mean that B equal to C. And A into 0 matrix will be a 0 matrix. Suppose AB is a 0 matrix. A matrix is something, B matrix is something, the product is a 0 matrix. That does not necessarily mean that A is a 0 matrix or B is a 0 matrix or AB is a 0 matrix, as in the case of normal algebra. A and I will be equal to I into A. So these are the properties of multiplication of matrices. Now I am taking an example for matrix multiplication. Matrix multiplication is a little bit problem for many students. How to multiply the two matrices? First you look into that whether the orders are, the condition for order is satisfied. That is, column of this one must be equal to rows. So here is 2, here is 2. Yes, it is satisfied. I can multiply. The AB is defined or AB is possible. What I am doing is that the first element of this one, 6, is multiplied with the 1. 6 into 1 and then plus. Second one with the second one, minus 2 into minus 2 plus 4. That is A11 with B11, A12 with B21. 6 into 1 and then minus 2 into minus 2. So 6 plus 4, 10 in the first column. Now for the second column, 6 into 5, then minus 2 into 4, so minus 8. Similarly, second row with the first column, minus 3 into 1, plus 5 into minus 2, that is minus 10. Similarly, second row, second column, minus 3 into 5, and then 5 into 4, so minus 15 and plus 20. So now simplify that, 6 plus 4, 10, 30 minus 8, 22, minus 3, and minus 10, minus 13, and 20, minus 15, 5. That's our answer, AB. For the same problem, I am doing BA. So I have written first B matrix, and then secondly I have written the A matrix. Now start multiplying that. 6 and then 5 into minus 3. For this one, 1 into minus 2, 5 into 5. Second row with the first column, minus 2 into 6, 4 into minus 3. Second row with this second column, minus 2 into minus 2, 4 into 5. Simplify that, you are getting minus 9, 23, minus 24, 24, which shows very clearly that AB is not equal to BA, which I said that the matrix multiplication is not commutative. Similarly, we can go for 3 by 3 matrix also. So that we will be doing when we are doing the problems. So in today's class, we have seen what do you mean by matrix, or what is the order, what are the different types, how to add or how to subtract, what do you mean by negative matrix, what is unit matrix, and then how to multiply two matrices, which is very important, and also the properties. Now, with this, having understood all these things, we will see the multiple choice questions in the next class. So, for which I am expecting you to be thorough with the concepts. We will see for the MCQ in the next class.